Hello, let's work now on a polynomial p of x and verify that -3 is a zero of this polynomial. In order to do that, we can follow two different ways. Either we are going to work with synthetic division, and we will prove that the remainder of the polynomial is equal to 0, and use the remainder theorem. Or we can actually plug in the -3 into p of x and find that the result for that is equal to 0. Both ways are good. The advantage of working with a synthetic division is that we will not only prove that the remainder is 0, but we will also find what is the quotient of that division. So we write -3, that is the 0 that we try to prove, and the coefficients of the polynomial. In order to complete the division, the first step is to bring down the first coefficient, that is the number 1. So we bring down the number 1, and after we do that, we take the number that is under the line and we multiply it by -3. Remember that we will repeat the same step. Now we take the -3, we write it on the second column, and we add the two numbers. The result is 0. We repeat, so we multiply 0 by -3, and the result is 0. We add it to -16, and the result is -16. We multiply the -16 with -3, the result is 48. 48 and -48 is equal to 0. And this is going to be the remainder of the division. We can see that the remainder is 0. This is what the synthetic division gives us. So this means that -3 is a 0 for the polynomial. If you want, you may want to verify that by plugging in the -3 in the p of x and add and subtract the corresponding terms, and the result will be 0. Now, 0 is the r of x. But what we see, 1, 0, and -16 are the coefficients of the q of x. If we want now to write the q of x, I always start from left and go to right, increasing the powers of x. So -16 is the constant, 0x, and 1 times x squared. If I want to simplify that, this is equal to x squared minus 16. And this is the q of x. So, what have we done right here? We took the p of x and we divided by the d of x. What is the d of x? X plus 3. X minus the -3 that we tried to prove that is a 0. This is equal to q of x plus the remainder of the polynomial divided by the d of x. If we want to write exactly what this means for the specific polynomial, then we can do the following. X to the third plus 3x squared minus 16x minus 48, that is our p of x, divided by x plus 3 from the one side, is equal to q of x, that is x squared minus 16, what we found from the division, plus 0 divided by x plus 3, that is overall equal to 0. So pretty much the fraction that we see on the left is equal to x squared minus 16. So the p of x, the initial polynomial, is equal to x plus 3. This is one of the factors, since -3 is a 0, times the quotient, that is x squared minus 16. Now you can observe that x squared minus 16 is a difference of squares. And this, along with the -3, will give us all the zeros for p of x. x plus 3 is the first factor. X squared minus 16 can be written again as x squared minus 4, x squared plus 4. Each one of those will have a solution, and each one of these solutions will be 0 of the polynomial. So, negative 3, 4, and negative 4 are the three zeros for the polynomial. Observe here that the polynomial is of degree 3, so I do expect to have, in total, 3 solutions, meaning 3 zeros for the p of x.